Hello, everyone. I hope everyone is very well. So we were discussing about the AI. So in our, couple of videos has already been posted into the internet. The first one was the introductory session where we have covered what are the things which will be, talking. My last video was the part one of the linear regression. We have covered the most of the things. Today we'll be covering the remaining session. If you have not seen my previous session, so please find the previous video. Okay, we'll be giving the link of it, right? I'll not cover that part in this video. So, but I'll be definitely summarizing to you, and then the remaining part I will be covering. The key things is since the previous video was getting longer, so we thought that let's make it break. So it's the first part. And the second part we'll be talking in this video. So basically, the linear regression we were talking. Linear regression is one of the very famous algorithm on the regression under regression of the supervisory learning. And we were talking about the R2, right, which is the coefficient of the determination, right? So basically, why we need the coefficient of determination to find out what is the efficiency of the model. We have learned from the previous session that a model, when you are building, we need to see how much is the error. Error means nothing but the actual minus prediction. That is very much important, because what is the, when you are asking a model to predict, you should know how much is the error is coming, and so that you can reduce that error, right? That is the main agenda while creating a model. You need to reduce the error. And while we are reducing the error, at the same time, we need to check how much is the efficiency of a model. So when we are checking with the efficiency of the model, we need to calculate the R square. So R square is called coefficient of determination, by which we can, we can find out the efficiency of a model. So look, this is the data which has been given. This is the y hat, right? So x is the input for us, y is the output for us, and y hat equal to 2x plus 2, right? 2x plus 2, this is what which has been, we have taken for the model formula. Now, what we want to do it, what is the R square value for it, right? So look how we are calculating. So very simple. This is the given data. We are writing x here, and we are writing y here. Y is the actual, and we are saying that the prediction equation is y hat equal to 2x plus 2. So this is very important. So we need to see that for this equation, how the model is predicting. Is the model is predicting very similar to the actual? If yes, then very good. So if it is not doing the prediction similar to the actual, that means this formula you need to tweak it. You need to tweak it in such a way so that your prediction values should be very similar like your actual value. That is our main target, so that you can productionize that model, and you can see you can get the best result. But remember one thing, that when the model is going to the production, you always into your intention should be to verify that model, verify the model, or monitor that model using the observability. If there is anything which is deviating from the current state, then certainly what you need to do, you need to bring that model again into the lower environment, do the retraining, and again you need to publish that model. So this is the overall idea which in a MLOps project which you do, which we'll cover in subsequent time. But very, very important for today to understand this part. So we have given the data. Now, first step is very simple, very, very simple. The first step is calculating the y hat. So y hat equal to 2x plus 2, which has been given. So we have the actual, we have x value. So we are calculating y, what is the y hat value. So 0, 2, 4, 6, which we are getting because we have x. So if I put minus 1 here, so minus 1 into 2, what is minus 2? Minus 2 plus 2 equal to 0. So y hat value is 0. So for all the input, we have calculated what is the predicted output. Okay. Once we have a predicted output for this particular model, we need to see what is the error. So the very important part is the calculating the error. So error is y minus y hat. That means we have the actual, as I say, to calculate the error means y minus y hat. So we are calculating y, and we have the y hat. So 1 minus 0. So we are getting the error, which is y minus y hat, that is 1. So for all the cases, we have got the value of error, right? So once we have got the error, the next stage is we need to calculate what is the error square. Very simple. So we are calculating error square here. So till this point, I hope it is very much clear. There is no doubt, right? Now, once we calculate the error squared, our next step is we need to calculate sum of squared errors. So how much is the sum of squared error? We have just do the plus. So when you do the plus, it comes as a 4, right? So that means this is the sum of error squared. Next, so till this point is fine. So this is the SSE, which we have just got how much total error has happened for given input. Very, very simple. Think very simple. I'm telling you, AI is the most easiest part in the world. And that is why people are learning AI. That is why our technology is going high. Only thing is that you need to know how to calculate. Another thing want to call out to you is, see, few people who are not good in maths, they get a fear that can I learn machine learning? I am committing you. I will be teaching you like a way that you will be certainly learn it. It is very simple. Only thing is that you need to remember few of the formulas. That's it, right? So, okay, let's move on. So now the calculate mean of y. So now SSE we have got, but what is our target, sir? Our target is to calculate the R square. This is the formula. As I say, we need to remember that formula. R square is 1 minus SSE by SST, right? So now the calculations we have done for SSE. Now this is the calculation for y. Y is nothing but a median. So we have mean. So we are calculating mean 1 plus 3 plus 5 plus 7. Where from we get this number, sir? Very simple. We have get this number from the actual. So we got that actual number because that is the y. And then we have just calculating the mean with saying the y bar, right? So 16 divided by 4, which is 4, right? Now we need to calculate what, sir? So we got SSE. Now the next thing is that SST, right? So when we are calculating the SST, it is nothing but a total variance. And what is the formula of total variance? Formula of total variance is simple. SST equal to summation of y minus y bar whole square, right? And we have the y. We have y minus y hat, y dash. What is that number? 4. So y minus 4, we are calculating the value, right? And then just do the square, right? And then make it total because this is a summation. So summation means you need to make a total. So you are getting 20. And then the R square value is 1 minus 4 divided by 20, which is 0.8. Now, very, very important, which I will be talking. So you have got this value. So this is the theoretical concept which I have explained. But the question is why you will be doing this calculation, right? And what ML engineers perform this calculation? Do they do in the notebook to calculate? No, they don't do anything in the notebook. They all do in the Python code. Okay, we'll come on it. But what I'm saying it is here is very simple, that when you have this calculation 0.8, what is 0.8 means? 0.8 is nothing but the 80%. So 80% your model is accurate, right? So when see it's a prediction, again remember, it is when it is a prediction means model will be not giving the actual result, right? What we can tell into the machine learning area is model is telling 80% correct, right? 80% correct result model is giving. Okay, yeah, if it, and our intention will be to make sure the model is giving 100% of result, right? If we can do it, that means your model is perfectly working fine, right? So that is why 80%. And how you can make it 100%, you just need to tweak this bit. Which bit, sir? This prediction equation. So you need to tweak that prediction equation in such a way so that you will get the 100%. If you get the 100%, your linear regression model will be predicting the nice way. So this is the overall things. I hope you all understand this very, very simple thing. You need to calculate R square coefficient of determinant. Determinant is saying, what is the total number of error, and after doing the mean, what is the total variance you are calculating. So 1 minus total error divided by total variance, right? That is your R square. And when the R square value is tends to 100%, that is what your model is good. When it is coming to the, coming towards 0%, that means your model is not performing well. So this is the way we calculate R square to find out your model is perfect or not. I hope it makes sense. So this is what I want to cover today. And last point before we close today. So how, this has been calculated by the ML engineers. Do you think that ML engineers write any code and perform it? I said no. ML engineer ML engineers perform code to do it. They do not write it in manually, right? So there is a way to do it. right? I'll open coding where we have done, so that you can see how the coding has been done, and you can practice it in the Google Colab. So very simple. I need to just open my existing Google Colab so that we can utilize our time. So linear regression, right? So in Google Colab is the system where you can easily perform your, anything on your coding, right? So see, this is the model coefficient which we have created, model intercept which we have created, and then the model prediction has been created, right? So I hope you understand the linear regression, right? So our next target will be to continue with the logistic regression. So in our next session, we'll be covering in details of logistic regression. But what I want to mean is, if you have any doubt, any confusion, any topic, you please WhatsApp me. We'll be talk in the Bengali. We can talk in the Hindi. We can talk in English. We can, we can, our intention will be to ensure that we all learn together. It is not only for the coders, as I said, it is for everyone. And we'll be trying to explain this video in the layman English language. That is the main thing. And if we don't know AI, I'm telling you, trust me, in tomorrow's world is very difficult for us to sustain. Just think about the situation when the computer came, right? So when computer came, we many people lost their job, but there are many areas where the new jobs has been started, right? We know today also, if there is a IPL going on, there are new strategics there who is actually thinking on the computer. So everywhere is the computer now. I'm telling you, after 2 to 3 years later, everywhere will be AI. So this is the area when we need to learn AI. If we don't learn AI, it will be very difficult for us to sustain. If you are a coder, if you are non-coder, if you are just a person who is not doing anything, also you should learn AI. Okay, and we'll be explaining you in the simple language, and I'm telling you, AI is the most simplest part in the world. Just you need to follow some things, and which I'll be telling to you every day every sessions, etc. So just follow me and then grow yourself. Thank you, everyone. So keep smiling, and we'll be meeting to the next video. Till then, salute. Thank you. Take care.